There's a recording for the circuit labs, and one applet that is really nice is the PhET, Physics Educational Technology. So search for that on the internet and then go to the one on circuits. And let's see, I should have it here very quickly. Let's do DC only. And there it is. Okay, not everything shows here, so I'm gonna see how I do that. I want to just grab a light bulb, grab a battery, grab a switch perhaps. I'm gonna turn this way, and a wire, and another wire, and again, and one more. Oops. Be a little bit careful here because it kind of jumps around here if you accidentally click it on the wrong thing here, then it's kind of tough to get away from it. See, it always wants to move there. So if you accidentally get it there, well, that would be actually a short circuit here. And you could see that that produces some fire in the battery. Anyway, so now I got to connect it correctly, and I close the switch, and it glows quite brightly. I'm going to put a second battery here in here. And basically, I'm just playing around with this here to show you that this is how the applet works. There we go, and close it, and there it is, quite brightly. Okay, now I'm going to put one in parallel, I wanted to say, but I think I wanted to measure something. I'm trying to grab the switch. There it is. So I'm going to put actually another light bulb in here. And there. I'm using too many wires, but I'm just not sure if I need to break it up here at some point, so that's why I use so many. Okay, and then I close the switch again. And it's actually equally bright as it was before. Notice that if I break that off here somewhere, I'm trying to pull it away there, that this is the same brightness no matter what. So in parallel, it actually gives the same brightness for both lamps, which of course means that these two lamps must be using twice as much power. So one of the answers to the questions on the lab would be where it says connect 3 light bulbs in parallel. Sure, I'll connect a third one here. It's probably going to be slightly out of the picture. So there we go. So they're all in parallel. And it says what happens to the brightness of each light bulb when they're connected in parallel, and the brightness stays the same. They're equally bright as if there was only one of them in that circuit. Measure the total current. So that's what I'm going to do. I'm going to open this one here, and if I want to measure the total current, I have to interrupt it in the place where I want to measure it. So here, that's where I would measure the current. There's the ammeter. It just popped up here. Okay, it looks like a little bit out of the picture. There we go. Oh, yep. Now I need another wire. And let's see if we can actually read that. Oops. Then I can't read it. Split the junction. Still cannot read it. Where did I put it so that I actually can read it? Try it this way. There we go. Connect it. Close the switch. And it says 5.4 amps is what I measure here. for how long would the light bulbs glow, and for that I have to look at the footnote, and it says the capacity of one regular alkaline AA battery is about so and so much, and a C battery so and so much, and so on. So I would have to see what kind of battery am I actually using, and I know that these kind of look like a double A battery, but they're not. This is a 9-volt battery, so it says here that a 9-volt battery got only 0.5 amp hours. So I take the 0.5 amp hours. Of course, I have two of these here, which is 1 amp hour, and I divide that by 5.4 amps, and I come up with approximately zero point 0.2 hours, which is about 12 minutes or so. And I think we can see that these light bulbs are so bright that if I have that large of a current and I put two batteries in here. Oh, I take that back because I have two batteries. I actually have twice. No, that's right. One amp hour divided by 5.4 amps, and that comes out to zero point 0.2 hours, which is 12 minutes, and then the batteries are gone. Anyway, this whole thing was just to show you how to set up a circuit with this applet.